Hello everyone, welcome to a new mathematics class. In this class, we are going to learn the second chapter of our textbook, Polynomials. Before getting into this chapter, we need to look at some of the prerequisites that you have already learned in your last years. First of them is, what is an algebraic expression? You know, an algebraic expression is an expression or a mathematical statement comprising numbers and literals. By literals, we used to represent some unknown quantities by the letters x, y and z, right? So a combination of these words or literals and numbers along with the four arithmetic operations or arithmetic symbols plus, minus, multiplication and division form up an algebraic expression. So the first thing that you should know what is an algebraic expression. I'm going to give you some examples. So this is our first topic or first statement, algebraic expression. I'm going to give you some examples of the same. So at the same time, while you are listening to the class, make sure you are noting down all the details. We won't be giving, or it won't be, I will be giving classes only, no notes, of course. So you'll have to make notes by your own. I hope you will do the same. So I will give some examples. Some of them are 7x squared plus 3x. This is an example for algebraic expression. You can see numbers and variables being written together, separated by the arithmetic operations. Also 7x cube by 7x cube minus 1 by x square, then 3x raised to 4 by 7x raised to 5, etc. Or all are examples of algebraic expression. I hope you know that. Now let's see what is the next thing that we need to learn. Terms. What do you mean by terms of an expression? Terms simply means the characters in the algebraic expression. It's very simple as it is. See, in the first expression, so how many expressions are written in this board? Okay, we will catch up with the same. Plus 7y plus 4. Okay. We have written three different algebraic expressions in our whiteboard. First one is 7x squared plus 3x. 7x cube minus 1 by x square, 3x raised to 4 by 7x raised to 5 plus 7y plus 4. For our example, I will give you the simple one, 3x raised to 4 plus 7y plus 4. What I mean, or what term means, is that the number of characters in one expression. Consider the first expression, 7x squared plus 3x. How many terms are here? Just two terms. And which are the terms? First term is 7x square, that's one term. Then next term is 3x. I hope you get it. In the second expression, how many terms are there? There are also two terms are there. First one 7x cube. Then next one is minus 1 by x square. Minus 1 by x square. So I hope that's clear. Last one 3x raised to 4 plus 7y plus 4. How many terms? Three terms are there. Which are they? 3x raised to 4 plus 7y plus 4. So I will write number of terms is equal to 3, because there are three terms. I hope you got the difference. Then next, so we have seen what is an algebraic expression, what is a term, and then let's see what are coefficients. Coefficients are very easy thing. We all have neighbors in our house, right? The same way, in an algebraic expression, the term that is lying in the neighborhood of 1 is called its coefficient. Look at the example. The term 7x squared in the first expression, 7x squared. 7x squared is a single term, right? How it is written? This is written as 7 into x squared. So we will say the coefficient of x squared. The coefficient of x square is 7. Coefficient of x square is 7. You can say in the vice versa way also, that is coefficient of 7 is x square. But normally we will be asked to write the coefficient of the variable. So in this case the variable is x square. The coefficient of x square is 7. I hope that's clear. Look at the second term. What is the coefficient of x? Can you say by yourself? Yes, coefficient of x is 3. Coming to the next expression, 7x cube minus 1 by x square. Then what if I ask, what is the coefficient of x cube? Coefficient of x cube is clearly 7. Is that clear? Now, let it be here. Next expression, 3x raised to 4. What's the coefficient of x raised to 4? It's 3. Coefficient of y is 7. Now, 4 is a constant term. It does not have any variable in with it. Okay, fine. Let it be there. So we have seen what is a coefficient. Now we are getting into the next important part. What is a polynomial? Now, some of you would be having a doubt that polynomial is not the same as algebraic expression. It's to an extent it is same as an algebraic expression, but with only one condition, and the condition is that the powers of all the terms in the algebraic expression should be a whole number. So polynomials are the expressions whose powers are whole numbers. The variables powers are whole numbers. Let's see with examples. So I would recommend to go through your textbook and to write all the definitions of the terms that I have written here. So I would recommend you to write down all the terms first, then find the definitions for everything in your textbook, and then if you watch this video it will be very crystal clear for you. Okay, now let's move on to the next part. What is a polynomial? So I have just told you the definition of a polynomial. So that's it. Now let's see some examples for some polynomials. In another way we can say some examples and non-examples. For example, expression 7x cubed plus 3x square plus 9y. This is clearly a polynomial. Why? Can you guess why? Because all the variables, that is x cubed, x square, y, has the powers who are whole numbers. 3 is clearly a whole number, 2 is a whole number, y is also, y means y raised to 1. 1 is also clearly a whole number. So this is a polynomial. Now 7y raised to 4 plus 21x raised to 5 plus 9z. Is this a polynomial? Yes, this is also a polynomial. Now 7z cubed by 7z raised to 5 plus 21x raised to 7. We have learned in the last chapter how to manage the powers who are lying in the denominators. I hope you remember that. The laws of exponents in the section laws of exponents in our first chapter, we have learned how to manage this person. So let's see, 7z cubed by 7z raised to 5 plus, okay, this can be written as, how will you write this one? This is same as 7z raised to 3 minus 5 or 7z raised to minus 2. So this expression becomes 7z raised to minus 2 plus 21x raised to 7. Now my question is this a polynomial? Is this a polynomial? What is the condition for an algebraic expression to be a polynomial? For an algebraic expression to be a polynomial, all the powers of the variables should be whole numbers. Now look at the power of x here. Power of x is 7. Is that a whole number? Of course that's a whole number. Then next one, what's the power of the other variable? It's minus 2. Is minus 2 a whole number? No. So this expression is not a polynomial. This is just an algebraic expression but not a polynomial. Now I will write down some examples and non-examples over here so that you will understand what's the difference. So I have written some of the examples and non-examples for a polynomial. I would recommend you to pause the video and find by yourself whether these polynomials are, these expressions are polynomials or not. I will be explaining anyway. First one is x plus 3. Is this clear? Is this a polynomial? Of course it's a polynomial. The power of the variable x is 1. So that's a whole number. So clearly that's a polynomial. Coming to this example, root x plus 3. What is root x? Root x is nothing but x raised to 1 by 2 plus 3. And the power of x is 1 by 2, which is not a whole number. which denies that the expression is a polynomial. So this is not a polynomial. This one, x square plus 9x, is a polynomial. X raised to minus 3 plus 5. X minus 3 is not a whole number, so that's not a polynomial. Then x raised to 4 plus 12, y raised to 5. No problem with the powers of the variables x and y, so that's a polynomial. Then x raised to 1 by 4. 1 by 4, is that a whole number? No, sir, that's not a polynomial. Then x raised to 12 by x raised to 8. How will you write this one? X raised to 8 by x raised to 12 by x raised to 8 is x raised to 4 plus y raised to 9 by y raised to 5. It is y raised to 4 plus 3. Is this a polynomial? Yes. So that's a polynomial. Now what about this one? X raised to 3 by x raised to 9. That is 1 by x raised to 6 plus y raised to 5 by y raised to 9 is 1 by y raised to 4 plus 3. Taking this x raised to 6 to the numerator, I hope you remember this one. X raised to minus 6 plus y raised to minus 4 plus 3. Is this a polynomial? No, this is just an expression. It's an algebraic expression but not polynomial. This has no enough condition to become a polynomial. So I hope you remember this part. Then moving on to the next part, polynomial in one variable. So we have seen some polynomials of one variable. I will specifically say what does that actually mean. So here we are, polynomial is done. Now polynomials in one variable. For example, we have a polynomial x plus 5. How many variables can you find in this one? Just one, right? What about y plus z is equal to 3 or y plus z? Just a polynomial. How many variables does it have? It has two variables. So this is not a polynomial in one variable, but this one is. I hope you remember, I hope you got what is a polynomial in one variable. The polynomials in which there is only one variable is called as polynomial in one variable, and the variable can be repeated with different powers also. I hope you remember what's the power. Here is an example: 2x raised to 5 plus 2x raised to 9 plus 3x raised to 2 plus 1 by 2x square. I have purposefully written a non-whole number as a coefficient. What's coefficient of x square here? It's 1 by 2, right? This is still a polynomial because don't get confused. The powers, only the powers of the variables should be whole number. Coefficient can be anything. Is that clear? Now, let's see this one. In this expression, in this polynomial, there is only one variable. Who is that? Yes, the variable x. There is no other variable other than x. So this is clearly a polynomial. It's a polynomial in how many variables? In one variable. That's it. So that's the definition for polynomial in one variable. Here is a non-example and here are two examples. If you need one more non-example, then I will write down 2y plus 3z plus 9x square. This is not a polynomial in one variable. So here is a non-example, here is an example, non-example, example. That's it. Now next part is constant polynomial. Let's see what is constant polynomial. Constant polynomial means there won't be variables at all. That is, only what are constant? Constants are the values whose values or numbers whose values does not change. For example, the number 5. Is this going to change at any circumstance? No. This 5 will remember as 5 as long as it stays. Okay, this one is clearly a polynomial. This one is clearly a polynomial because I will show you why. Because 5 is nothing but 5 into 1. Am I right? And for example, we know any number to the power 0 is 1. That is 100 to the power is 1. 100 to the power 0 is 1. 1000 to the power 0 is 1. Similarly, x to the power is 1. So, can I substitute this as 5x raised to 0? Yes. Now this is clearly a polynomial. Even though it is 5x raised to 0, we only used to write it as 5. So only thing that you need to understand is by what is a constant polynomial means. So I'm going to write constant polynomial. Constant polynomial is nothing but the polynomial in which there is only a constant. Example 3. That's an example. 100. That's another polynomial. Which type of polynomial? Constant polynomial. Then 120, 130, etc. All these are constant polynomials. Now, next one is zero polynomial. Now, let's see what is zero polynomial. Zero polynomial is one kind of constant polynomial, but instead of the number, there will be only one character, that is 0. So 0 is called a zero polynomial. We are going to learn some other terms based just like sounding just like zero polynomial, so don't get confused. Learn by now itself. Zero polynomial means the polynomial in which there is only one term, and that is 0 over. That's it. Now, next one is denotation, or how will you represent polynomial? Denotation, or how to write, how to represent polynomial. Representation of a polynomial. We have learned so many polynomials: x cube plus 3x square plus 9x. This is a polynomial, right? We used to represent this polynomial as some p of x. How will you write this one? P of x. Then say another example: p of x is equal to 3 or 3x. P of x is equal to 3x. Now we used to represent it as p of x or r of x or q of x. Then I will say r of y, r of y. This is another way. This is the way of writing a polynomial. So learn now itself. You can write polynomials just like this. R of y is equal to 3y square plus 9y, or you can say q of z is equal to 3z square plus 4. This is the way to write polynomial. So like p of x is equal to r of x is equal to q of x is equal to. Generally it is written in this format. That's all. Now, so we have studied this one, constant polynomial, zero polynomial, and how it is denoted. Now the next part is degree of a polynomial. This one is a very important part in our chapter, and we will classify the big collection of polynomials into different categories based on this degree. So this is an important part. Listen very carefully. Degree of a polynomial. So degree of a polynomial. Let's see what the definition says. The highest power of the variable in a polynomial is called as the degree of that polynomial. The highest power. So we have learned there will be variables. So we are talking about the degree of a polynomial in one variable. So the following says the following will have only one type of variable in this whole polynomial statement. In that, the highest power of the variable, that is called the degree. Now let's see some examples. P of x is written as 7x square plus 3x. Then what is the power of x in this term? 3x power is 1. What about 7x square? What's the power? 2. So which one is the highest power? This one. And what is that? 2. So the degree is 2 over. In this case, 9y cube plus 7y raised to 4 plus 3y. In this polynomial, which is the highest power? Is it 3, 4 or 1? It's 4. So the degree is 4. In this one, we don't have to be bothered about the coefficient and all. We just need to look at the variable. Look at the variable over here. It is z, right? The power of z. What's that? 1. So the degree is 1. P of y is equal to 2 minus y square. What is the power of y here? 2. And is there any other terms with power more than 2? No, so the degree is 2 again. Now 5x cube plus 4x square plus 7x. In this polynomial, who has the highest power? This first term, and that power is 3. So the degree of this polynomial is 3. Now 5t minus root 7. Power of t is 1. So the degree of this polynomial is 1. That's all.